Hello and welcome to the Evelyn Y. Davis Studios at the National Press Foundation. Today we're talking about artificial intelligence and what journalists need to know about AI.
The National Press Foundation is a nonprofit dedicated to helping journalists cover complex topics with depth and accuracy. We serve journalists in the U.S. and around the world.
I'm Sandy Johnson, President of the National Press Foundation. With me in the studio today is Daniel Castro, Director of the Center for Data Innovation, and Matthew Hutson, a freelance journalist who covers AI for Science Magazine and other publications. Thank you for joining us. So we already see artificial intelligence in our daily routines. What are some everyday applications of AI that people are already using?
So depends on how one defines AI. So some common applications might be web search, or speech recognition, or driving navigation, spam filtering. Then there are a lot of behind-the-scenes things that affect people's daily lives, but they may not realize it, like fraud detection. Credit card companies use these, or running infrastructure, increasing efficiencies, or shipping, or financial markets, things like that.
Mm-hmm. Daniel?
I think a lot of people have used tools like Google Translate, which is one of those really great examples of how artificial intelligence really works today, where what Google's done is they've basically taken massive data sets of language online, and they've had the computers analyze it and look at common text, and they've been able to figure out the best ways to translate things, not by teaching the computer explicitly this is this word in English and this is this other word in Spanish, but by just letting the computer learn and figure it out. But really we're seeing AI being integrated behind the scenes in so many different technologies, in healthcare and manufacturing. When you look at all the developments around clean energy, a lot of the work around solar energy and citing some of these green energy solutions, it really depends on using AI to automate decisions about where you put things and how to respond to just massive amounts of influxes of data.
Mm-hmm. So let's get a little bit deeper. Let's define artificial intelligence and how it works. And our audience is journalists who may not know much about the science or the technology, so let's try to keep it simple.
Sure.
Daniel?
So AI at its core is really it's a field of computer science that's focused on creating systems that can do things that are analogous to human intelligence, whether those things are learning, percepting things, interacting with the environment. A lot of it involves pattern recognition or other types of interpretation. And that's, at the core, basically what it is. Some people have associated, there's kind of two types of artificial intelligence. There's narrow AI, which is using those functionalities to solve very specific tasks, like translating a document. And then there's what's called artificial general intelligence, or this idea of a computer that is basically equivalent to a human, that can do all the things a human can do, that can reason and think and be creative. And most of what we're talking about with the development of AI is really all around narrow AI. If you're going to the movies, that's artificial general intelligence. That's the idea of the Terminator or all these other movies that we see out there.
Mm-hmm. And Matt?
I think it's also worth emphasizing that there are two broad methods in AI. So there's rule-based AI. Basically, you're telling a computer to follow certain rules. If this, then that. So if you're teaching a computer to recognize dogs, you might say, if this animal has 4 legs, if it has fur, if it has a tail, if it barks, then it might be a dog. And then there's what's becoming more common today, which is machine learning. Mm-hmm. So you would just show it lots of examples of things, like pictures of dogs and pictures of not dogs, and say these are dogs, these are not dogs. And in machine learning, the computer, it finds patterns in things that you're not telling it explicitly what rules or what clues to pick up on. It's sort of looking for those clues on its own.
And we've got 2 brief videos that will help illustrate artificial intelligence. Let's do the neural
networks.
Matt's video first.
So within machine learning, people talk a lot about deep learning. So deep learning is referring to neural networks. So this is a very simple neural network. So the input, there might be, so if it's a photo, you'll have more than 3 inputs. It might be 1,000 inputs, one for each pixel, like black or white or whatever color it is. And then there's a hidden layer that basically adds up the inputs and multiplies them by a certain number, and it manipulates the input slightly. And then those all go to the output. And in this case, there are 2 outputs. One would represent dog and one represent cat. And whichever number is bigger, that indicates whether it's probably a dog or a cat. And so commonly in neural networks, it won't be this simple. You might have dozens of layers. You might have millions of these little nodes, of these neurons, with billions of connections between them. And it requires lots of training examples. So you might have thousands or millions of training examples, pictures of dogs and cats and other things. So it basically, you give it examples, you'd say it guesses. There's a training phase before you actually put it into use. You give it examples, it guesses, you say yes or no. If it's wrong, it changes all of those sort of weights in between, all of the strengths of the connections between those things.
But this GIF is basically AI at its most basic.
Yes, this is a very sort of a toy example of a neural network or deep learning.
I think what's interesting for people to know about neural networks, it's an artificial neural network, right? And it's based on, of course, the biological neural network, which is our brains. So, I mean, one of the big breakthroughs here was basically, when computer scientists sat around and said, well, can we design a computer that's like the human brain, where, a child, you don't tell them this is a cat and say, well, a cat has 2 ears and whiskers and a nose. They just see lots of cats, and they recognize that that's a cat. And they also recognize not just a photograph of a cat or an actual cat in front of them, but they recognize that when you just take a little line drawing and you do 2 pointy ears and a little smile and draw some whiskers, that's also a cat. Or that something with a long tail is likely a cat too. And so, that way of learning things, the humans you can't really articulate, well, I know this is a cat because of these features. You just know it's a cat. That's the same kind of process that's going on with the computer. It doesn't really know this is a cat, but it knows it's seen things like this, and that is always cat, and it figures out what those little features are that make something the essence of a cat.
Yeah. So these are called neural networks because they're vaguely modeled on how the brain works. So the brain has 86 billion neurons all connected with each other, and basically there are little bits of activity that flow between each one. So each of those nodes sort of is a very simple model of a neuron.
Okay, let's look at this second video.
Yeah, so this is a video of, it's an Atari game called Breakout. And Google, I think this is a Google-produced video. They were training this computer on how to play this game. You can see at the beginning it's not very good. It's barely able to play the way maybe a toddler could play that can barely master the controls. But after a while, it gets pretty good. It can play the game and play as well as an average player. And what's really interesting is here, all it knows is sometimes it wins, sometimes it loses. It's trying to figure out the best way to play. So what happens here at the end is it actually figures out a new strategy on how to win that people didn't really use before, where it just sends the ball up at the top and quickly wipes out all the blocks. And it's a technique that the computer basically discovered and learned on its own. And this is a great example of how machine learning works, where at the beginning it doesn't really have much knowledge about the problem domain and what the solution looks like. It just knows sometimes it gets it right, sometimes it doesn't get it right. And it's through that iterative process of trying things and learning, and you can simulate this. So on computers that are running very fast in the cloud, it can quickly learn a lot, and learn, of course, much faster than a human can, and then get much better than a human can be after quite a bit of time.
It might be worth going into a little bit more technical detail on types of neural networks or types of machine learning. So broadly, there are 3 types. There's supervised, which is where you're giving it examples of labeled information. So you're saying, when it's learning, you're saying, yes, you're right, or no, you're wrong. You're supervising it. When there's unsupervised, where you just give it a lot of information, and it looks for patterns, it doesn't know what they mean. You might feed it a lot of email, and it'll say, okay, these are kind of anomalous. I don't know why. I don't know if that means they're spam. It doesn't know what spam is. It just says certain types of things stand out for some reason. And then there's the example of the video game, which is reinforcement learning. So it's basically trial and error. It's trying to do things in the world, and if it works, then it does more of that. So if it gets a high score, it'll keep doing that.
Okay, so computers versus humans, what does each do better? Maybe we should show the Jeopardy clip, since, it's 10 seconds, first of all, and it's one of the better known examples of how artificial intelligence works.
73 and a two-day total of 77,147.
I would have thought that technology like this was years away, but it's here now. I have the bruised ego to prove it.
So what are other examples of where AI has performed better than humans?
So AI is really good at pattern matching. There are a number of tasks that are fundamentally about pattern matching, and that's where I think there's some really interesting and great opportunities in the healthcare field. Because if you look at radiologists, for example, and you're trying to identify a tumor or identify something in a radiograph, those are the types of solutions where AI does really well. And what's interesting about those examples is that one, a computer is able to see more in its lifetime than any individual could see. So they have more expertise. And two, they're able to make calculations that a human couldn't make. So they're able to identify features or extractions in a lab test result and see something that basically no individual would be able to see. And so you see a lot of really interesting examples around that. There's also examples around, of course, just precision, where a computer can do something more precisely than a human can. The tasks where humans tend to be better are tasks that are creative, involve a lot of creativity, or involve human services. So we don't see AI kind of taking on jobs of providing assistance in a nursing home, for example, anytime soon, I think. At least most of the care that goes on there. We don't see AI being involved in criminal defense strategies. CEOs looking at what a company's strategy is. All of that's very complex. Even there's been a number of attempts to use AI to create music or create poetry. Those generally haven't gone too well. They're still in the learning phase. There are some that have worked out. Our AI has been pretty good at creating some kind of basic background royalty-free music. That's a simple example, but it hasn't written a top 10 hit or anything like that.
Mm-hmm. Yeah.
So there's some examples where you would expect a computer to outperform a human, like web search or navigation. And then there are cases where you would expect a human to be better, but AI is slowly getting better than we are. Like Watson, you'd think that humans would excel at that. Or things like chess. It was kind of a surprise when computers beat a grandmaster for the first time. Or the game of Go, another board game. Or certain things like making decisions about people in some cases, human resources, whom to hire or fire. Medical diagnoses, predicting academic performance. So these are decisions about human behavior that you think people would be better at. But humans have a lot of biases, and we're not always the most rational thinkers. We get distracted by certain bits of information. So sometimes it's easier to have something that just very cleanly looks at data and see what works and what doesn't, and doesn't have a lot of this sort of emotional baggage that we do.
Mm-hmm. So we have established then that there are many things that AI will be very good at because of efficiency and speed. And how will that affect the workforce? It's a big question, and one that's on everybody's minds.
Yeah, it's a question that's been around for a long time. I don't know if we've mentioned it yet, but AI's history goes back to the 1950s, right? And so when the concept of artificial intelligence first came out and people were debating this and talking about this a lot, they had many of the same questions that we have today about, should we be worried about massive unemployment? Should we be worried about AI basically taking everyone's job? And there were a lot of predictions in the 60s and 70s that are very similar to what we hear today about, you're going to be out of a job in a few years because computers are taking, the AI is going to take the job. And of course, that is part of a broader history of people being concerned about automation in general from technology. And there's been a number of proposals going back to the 1940s, 1920s about people basically asking questions around what would happen if we just get rid of some of these new tools that are being used to basically can we give everyone a shovel instead of using these power tools, and it will get back to massive employment. What we've seen in our work, looking back at occupational change over time, is that there's actually very little occupational disruption. So occupations change in the types of tasks that people do, but the occupations themselves don't tend to disappear very quickly. And in fact, right now we're at a fairly normal level. We don't see it changing that fast. And the reason for that is, of course, that technological change, the process of inventing something new can be quite quick, but the process of actually deploying innovations and scaling them out can take quite a bit of time. So you look at changes like the elevator, where before you had elevator operators and all of these buildings, and then you had the the self-operated elevator. It was until very late in the 20th century that occupation finally disappeared. And in fact, one of the few places it still existed was in Congress, where they had these requirements to still have operators there. So that tends to reflect, I think, what we actually see in terms of job change. There will be some jobs that might be fully automated. So for example, when we're talking about autonomous vehicles, once that is fully available, of course, we'll have significantly fewer drivers. But jobs like being a lawyer, that will likely shift, of course, with the availability of AI, but they're not going to be eliminated. And so the opportunity here is to say, well, can we really shift occupations that are low wage, low productivity, and move more people to these high wage, high productivity jobs? And what that means and what that's meant historically, and where I think there's often a lot of confusion, is people think, well, we're just going to have all these robots, and the only other jobs will be people servicing the robots. And people say, well, I'm, maybe I work in janitorial services. I'll never be able to be a robot service operator or something like that. And that's not really what we see in economic transformation. What you see in these types of economic transformations is that people's income goes up, and so they start spending money on things that people with higher income spend money on, which are things like travel, education, restaurants, entertainment, insurance, these types of things. And so those are where the new jobs are. More people want to eat at a restaurant, there's going to be more restaurants. More people are going out for coffee, there's going to be more baristas. More people want to buy art, there's going to be more artists. So that's where the opportunities are. So it's not that kind of all the jobs disappear and the only jobs left are those kind of building robots. It's really that the low wage jobs disappear, income goes up, and where people spend higher income, those jobs are the ones that grow.
And Matt, you've got a slightly different take on it.
Well, there are two sides of the debate, and it's still an ongoing debate. Some people say that automation will just lead to massive joblessness. Others say that the lost jobs will just be replaced by new jobs. If you look at in 1900, 40% of the workforce was in agriculture. Today, it's something like 2%. That doesn't mean that there's 40% unemployment. Those people are just doing other things. And right now, unemployment is still pretty low, even though we've had many years of AI progression. But then things might be different this time. Maybe it's sort of a slow build, and in 10 or 20 years, this sort of technological revolution will be different than the Industrial Revolution or the Agricultural Revolution. So this is something that people are still heavily debating. If you look at the types of jobs that will be changed, if you can imagine 4 quadrants, there are cognitive, and then manual jobs, and then routine and non-routine jobs. So manual routine jobs like manufacturing, robots are taking over a lot of those jobs. Cognitive routine jobs, AI is moving in on that territory. Things like simple data analysis or scheduling meetings, things like that. Then non-routine cognitive jobs, those will be slower to be changed, but AI is still moving in on that, like design or human resources decisions. And then there's non-routine manual jobs. Those might be the last to be completely replaced. Things like waitressing or nursing. It's still difficult to get a robot to even fold a piece of laundry, let alone like move around a hospital or a restaurant and take care of all of these different things and deal with other people in a fluid way. And then one thing that I think everyone is agreeing on is that it's not going to be necessarily entire jobs that disappear. It's more tasks that are being replaced. So in any job, there might be smaller tasks that can be automated, but you're still going to have to do other things. Like in radiology, for instance, it's not just reading the scans. So even if AI is better than a radiologist at detecting cancer in an X-ray, the radiologist still has to make decisions about how to treat the patient, how to communicate with the patient, what kinds of scans to take, communicating with colleagues, communicating with patients, all these other things. So even if one part gets automated and replaced by AI, that doesn't replace the whole job.
And I think that's what's been so kind of misleading about some of the studies that predict, massive unemployment. A lot of them look at current occupations, and they use, from, for example, Bureau of Labor Statistics will have some analysis of this occupation, involves this much, cognitive ability, dexterity, and physical exertion or something like that. And then they, came up with this formula, and they said, basically, if, this job combination is above this number, it can be automated. If it's, below it, it won't. And there are 2 problems with that. I mean, one is it kind of broadly lumped in a lot of jobs that probably won't be automated. So for example, one of the most kind of famous studies said that fashion models would be part of this automated group. Japan tried having a robot walk down the runway once. It was never very popular, and I think the models are safe for the time being. The second is that the occupations, as we said, they're going to change, and so even if you look at what could be automated in today's jobs, that's really the productivity opportunity improvement in these jobs. That doesn't necessarily mean these are jobs that are going away. And so I think that's where, just like with the computer, we had so many more opportunities to increase jobs, and it wasn't that everyone became a computer expert, but now everyone types, right? And so that skill became a core part of the job, and people took on new tasks too that they didn't have before.
And what types of jobs will increase or grow with AI?
Yeah, so I mean, I think we'll definitely see, as I said, some of these higher income areas, that's where there'll be a lot of growth. So as people get more money, they want to send their kids to schools with a higher, ratio of teachers to students, right? Or a lower ratio, more teachers. They want to do more travel, So all of these areas, that's where we're going to see a lot of the growth. I think, it is a mistake to say that technology itself will create more jobs than it destroys. I mean, historically, we know improvements in technology do destroy directly more jobs, but that it's all the indirect jobs that come out of that. That's where on net, people come out ahead. So the kind of the important policy question, I think, for a lot of people is really, can people move between occupations? Can people have, do we have a flexible workforce? Do people have educational opportunities, not just at the beginning of their career, but at mid-stage and late in their career? Is there a strong social safety network for where there is disruption? And then, looking at how, government supports that, there's often a comparison made to trade and, the job losses that came out from, manufacturing and shifting overseas. in some ways that's an interesting parallel. One of the main differences is that AI is really about efficiency gains across the board. So you're not going to have those regional effects that you see with trade, where a certain town, they had one big employer, that employer goes away, and suddenly the whole town kind of dies. It's not just the main employer, but it's also all the supporting services. When you have AI as a kind of across the board improvement in productivity, you don't have those same regional destructive effects that you might see in some of the trade debates.
Mm-hmm. And Matt, what do you think? What jobs will increase?
I think pretty clearly jobs in technology will definitely increase. Computer programmers, robot wranglers, technicians.
What does a robot wrangler do?
Repair robots or keep them out of trouble. All kinds of corner cases where robots are they know what to do in certain situations, but in slightly weird situations they might go off the rails, and you kind of have to keep an eye on them and tweak them a little bit. So yeah, people who are fluent in technologies, either coding or learning to use software packages that they can take advantage of automation, or helping people sort of as an interface between people who can't use the technologies and people who can.
A great example of a job that didn't exist a year ago is in Waymo, which is Google's self-driving car service, that they're already hiring the operators for, if you're using their car service and you have help, you need help, you can press a button. And they have, I think it's 60 to 90 operators they've been hiring and training to provide services, as well as to monitor the safety and operations of their fleets. So it's a great example of a job that it's not necessarily, it's a technology-based job, right? It's a technology company, but it's not necessarily someone who has a master's degree in computer engineering.
Mm-hmm. And we're seeing the, we're seeing the impact of AI at the college level, because there are more course offerings having to do with artificial intelligence and more students signing up for those courses. Have you seen any trends along those lines?
Yeah, attendance or registrations in AI and machine learning courses at a lot of colleges is going up. Okay, there's a graph. Mm-hmm. So these courses are sort of overflowing with students. And then not just in colleges, but online, on Coursera and these other massively open online courses. There are people who are maybe at home or maybe they're in between jobs, or they have some spare time and they want to catch up on the latest technologies, so they're taking online courses on data science and machine learning and AI and programming. So that's also increasing.
Mm-hmm. And I think we've got another slide that shows an Indeed job chart that says, I think it's like there are 4.5 times as many jobs that require some kind of AI skills than there were just 5 years ago. So how does that show up in a job posting? Like what is the skill set that would be in the job duties or requirements that would indicate AI?
Well, they'll say, a lot of times they're looking for a data scientist, and so they're looking for someone with, the skills to use Python or some of these other languages. They might look for experience with specific machine learning packages like TensorFlow, or one of the deep learning packages. They'll also, what's interesting here is a lot of people, of course, don't have tons of experience. It is still a new field, which is one reason you see a lot of people moving to it, because you can advance in it quickly, you can get a job quickly, and you can also you see lateral movement where people who were developers, without necessarily a really strong statistics or math background, are taking one of these boot camps, and they're learning some of these basic skills, and they're starting to deploy it, because what we've seen over the past few years is that AI has gone from something that you had to be an expert in to deploy to something that's being commodified. So just like any developer now can use the cloud. As before, if you wanted to have massive servers, you had to be a network engineer. You had to have someone with lots of expertise in all these data storage technologies. Now you just plug into Amazon Web Services. Mm-hmm. It's the same thing with AI. If you have a data set, you can apply machine learning to it really fairly easily without significant guidance, and you can start seeing results pretty quickly. And that's why there's just really big opportunities to start using this technology in new ways because the barrier to entry has gotten so low.
Mm-hmm. And how can workers prepare for or train for AI influence on their particular position? I guess that would apply to employers as well.
Yeah, so there are these online courses I mentioned. It's becoming easier to learn these tools. As Daniel talked about, there are things like TensorFlow that really, there's a sort of a layer of abstraction on top of the coding, so you don't need to learn all of the mechanics. You can sort of in one line of code do a lot. And then on top of that, there's Keras, and it's just getting easier and easier, more user-friendly. So it's not as intimidating as it used to be to learn to program in AI. And I think just being on top of what the trends are in your industry is important. So what kinds of tasks are being automated? And you might not need to actually learn to code these things, but just learning new software, for instance. It might be reading a software manual or taking a tutorial in a certain application, for instance. And being proactive so that you don't sort of get left behind, so you're not caught off guard by what kinds of things are being automated. Asking people in the industry experts, asking your job, like, where do you see this position in 5 years, or where do you see happening in this area?
Let's talk about the limitations of AI. What can it not do right now?
Yeah, well, that list is actually bigger than the list of what it can do, right? There's there's just so much, right? The big applications of AI where there's been a lot of progress are things like robotics and natural language processing, computer vision, but we still have so far to go, right? We still don't truly have autonomous vehicles on the road. We don't have robots, bringing us our drinks, making us our food, waiting on us hand and foot the way we want. That's still such a long way off. There's also, just...
Can you quantify a long way off?
It might not be our lifetime.
Not
right?
our whose lifetime?
It might not be my lifetime. And that's, we tend to be over-optimistic about technology in its early years and what it can do. I'm someone who thinks AI can be transformational, but that transformation is still going to be limited compared to the potential of what we can dream up in movies and in novels. And so we have to kind of temper those expectations, I think, a little bit. Right now, we're focused on, I think, automating some of the most routine processes in our life, like scheduling meetings. I think what we can hope for are things that, the kind of pain points, going to the DMV, that's something that maybe we can automate.
Hallelujah. Yeah.
And focusing on those kinds of tasks. But we're not going to likely see, again, this kind of emergence of, the 24/7 robot waiting on us who can do everything and, who can be your, full-time companion and, serve all your needs. That's still a long, long way off.
Yeah, so these narrow applications of AI are really impressive, but general AI is a lot more difficult. It's sort of deceivingly far off. AI still doesn't have what we would call common sense. It can't sort of navigate in a flexible way in an unpredictable world. So even the video game example we saw earlier, so Google DeepMind taught their algorithm to outperform humans, the best humans at that game. But other researchers have shown that even if you modify the game a little bit, like just move one of the elements of the game a little bit, suddenly the algorithm doesn't know what to do. So humans would use common sense and say, oh, well, it's still the basic rules, the same premise, it's a ball bouncing around, but you just change one little thing and the algorithm, it's completely lost. A few months ago, there was a news story about algorithms that could perform reading comprehension better than people on a certain test. So it would read a paragraph and then answer a question about that paragraph, and it beat sort of a human metric. But this was basically, it wasn't a realistic test of what we would call reading comprehension. It was basically just searching for straightforward answers in that paragraph. Other researchers showed that if you just add another sentence that is sort of irrelevant, it completely throws off the question answering. So it's not, ready to write a dissertation about what it reads. So even these big wins where you say, oh, AI is better than people, it's still in a very narrow sense. It doesn't have the common sense or the flexibility to take what it knows and apply that to a new situation. Another example would be AlphaGo. So the Google DeepMind's program, that spectacular software that beat the best Go players at this board game. But the board is 19 by 19 squares. If it were to try to play on 21 by 21, it would have to start learning all over again. It can't take what it knows and just sort of apply it to a slightly different situation the way that a human with common sense would.
And where does the U.S. stand in terms of global AI competitiveness?
Yeah, that's it's an area where it's a challenge. I mean, right now the U.S. Is likely in the lead. There's a number of metrics that you can look at, but China very close behind on some of the research, especially. What is, I think, interesting or worrisome, depending on your perspective, is that the U.S. hasn't really developed a national strategy for AI the way that a number of other countries, China included, but also Canada, the U.K., South Korea, Japan, Germany, they've all really put a lot of thought to what's the future of this technology, what are we good at, what are our competencies, how can we increase those competencies. China's developed about a 15-year plan around AI with clear benchmarks for how it wants to get there at each step. Now, whether it'll be able to achieve it or not is an open question, but it, by 2030 plans to dominate the world in this space. And I think that's where it's there's a really important national competitiveness issue here, because in industries, especially our the traded sectors where we compete, it really matters if U.S. industries are adopting AI in the short term and they're leading in the adoption and use of the technology. Because I think if we're talking about narrow uses of AI, but narrow AI is still very powerful, and so. If you kind of go back to that video of the computer playing the game, the computer at the end, could beat anyone at the beginning, and that's kind of how the industries will be as well. If you're an industry using AI, again in those narrow ways, but using it very effectively, you're not going to, you're going to be able to outcompete a country that's not using it or doesn't have that capability, and that's going to lead to, that can lead to massive global disruption and rearrangement of industries and competition. And that's where, I think the U.S. should really be paying attention to these issues about where do we go from here, and are we really working on accelerating the deployment of the technology?
Matt, how do you see it?
One factor that people sometimes talk about in terms of the U.S. versus China is they say China has an advantage of data. So machine learning takes a lot of data to train and become good. And there are different expectations of privacy in China versus the US. So there's a lot of information about people that's online, and so the algorithms can use this information to learn about people and to make predictions. So that's one advantage that they have over us.
And why hasn't the US developed a national strategy?
Well, there's a lot of reasons Congress hasn't done a number of things. There is a proposal out there to do that. Congressman Delaney of Maryland has called for this. There are others who are, I think, interested in moving down this path. There's been a bill to develop a national research strategy around AI as well. That was introduced I think it was last week even. And there is interest in this, certainly from the research community. A lot of universities are doing this anyway, and industry are working on these issues. But there's not necessarily strong alignment. A great example of this is, the funding right now around robotics. A lot of it's specifically geared towards robotics that doesn't displace human workers. That's fine, but Japan's going to lead then, and robots are displacing human workers. And if we care about that market and we care about using that technology, we should be investing in that area as well. Japan it's really interesting. The difference in their approach, because they recognize that they have an aging workforce, and they want to have robots in caregiving roles. They want to see AI displace a lot of jobs in the short term, and they're not as worried about that. So they are investing heavily in those areas, and so that's where some of these tensions come up. That it's not enough to say, well, in our country we won't do it this way, because if you see the disruption happening globally, it's going to come here as well.
Mm-hmm. And we'll get to business in a second, but are you talking about then federal funding?
Right. Yeah. Federal. I mean, there should be, I think, more federal funding around AI, and also just calibration of research dollars that are already being spent, so it's aligned with particular goals about where we want to see the most development, based on particular industries where we're seeing the most progress.
And what federal funding there is funneled through what agencies?
NSF. DoD. I mean, there's DoD funding, of course, and I mean, there's some, in NIH or Department of Energy as well through the national labs, and that's where coordination can have a big impact.
So let's go ahead and talk about business development. How has the landscape changed in recent years in terms of chasing and developing AI?
The startup landscape looks different, in that now every other company includes AI or machine learning in their name, or now cognitive is the big word. Like, do you have cognitive? We have cognitive. So for not too long ago, AI was kind of a dirty word. It was seen as sort of this utopian thing. Like if you said AI, people thought you were foolish or kind of laughed at you. But now that AI has shown some big wins, there are these well-publicized things like AlphaGo and Watson, and then it's actually it's clearly making money in finance and healthcare and advertising. So previously there have been claims about AI, but that haven't come through. But now it's actually materially making money. So startups are mentioning AI, and venture capitalists are investing in them. And then there are a record number of mergers with bigger companies buying up these companies. And it's kind of, some people are saying that it's draining academia. A lot of professors are now receiving a lot of money to go off and join companies, and it's now who's going to be teaching the next generation of students in universities.
So startups, and what else, Daniel?
Startups, I mean, large companies, of course, are integrating AI as well into what they're doing. I mean, one of the kind of low-hanging fruits right now is around business process automation, robotic process automation. Basically, there's so many kind of bureaucratic functions that an organization does, whether it's in the government or business. Something like if you're submitting a leave request form or insurance claim, it goes to 5 or 10 people who need their signature and sign off. And some of this kind of early, very practical AI is basically allowing people to easily map out those processes and automate them. It's when we talk about some of these really innovative uses of AI with deep learning, that's not what this is, but it is very much using computers in an automated way in ways that we couldn't do before. And that's where there's some really also big wins right now for organizations, and where we're seeing companies spending money in the short term.
And in terms of, let's say, big business goals, I mean, are they all reaching for something different, or are they all sort of headed down the same path?
Well, I think it's a combination. I mean, all businesses are striving for increases in productivity, but they're also looking for innovative new solutions to kind of hard problems or new products, and that's where you see some really interesting applications. So there's a service I use to schedule meetings that it's completely based on AI. So it's a complete virtual assistant, but just for scheduling meetings. That's the only thing it can do. It can't do anything else. It's a great time saver, and you can certainly see how scaling processes out like that work really well. We're seeing more of that where there's a particular very specific problem domain that the company is developing a solution for, and they're starting to scale those up. But those are they're very hard because it's a very iterative process. You can solve maybe 80% of the problem with a lot of data, and then you have to work really hard to get that last 20%. So it's a viable product, and that's why I think so much of this change is going to be slow over the next few years. But once you get one of those solutions working really well, these are all pretty much cloud-based, so they can scale globally. They can scale very fast.
I think there's increasing overlap in terms of aiming towards the same goals in AI. So if you look at, for instance, Uber for car hailing, Google does web search, and Apple sells phones, and now they're all competing for like in the autonomous vehicle space. And then Amazon, they sell books. Apple sells phones. Google search engine, they're all competing. And Microsoft, Windows, Word, now they're all competing for virtual assistants and chatbots and things like that. So AI is such a big target right now. You have companies in different spaces in different industries that are now vying for the same talent, the same money, the same advances, the same customers. So the competition is heating up.
And what regulatory bodies have jurisdiction over AI?
So, there's a few. Right now, what's interesting is, there's this convergence, right, between, the kind of technology space and other industries. So, Department of Transportation, in the United States has jurisdiction, of course, over vehicles and the roads, but they don't traditionally regulate technology in this way. The traditional regulators there are the Federal Trade Commission, who would look at consumer concerns, or Consumer Product Safety Commission, which actually just recently had an open call for comments around connected devices and some of the consumer safety concerns around there. So you see this convergence now of oversight. Similarly, you have traditional regulators in financial services, where there's been a lot of oversight of automated trading, robo-advisors, those kind of services. The question I think a lot of regulators have is, one, have they brought in the right talent so that they can actually have effective oversight, so that they can understand what companies are doing? And two, is that, what's the right way to regulate it? Do you regulate the code itself and kind of tell the companies what they can and can't do? Do you regulate the inputs, or do you regulate the outputs? And so there's a lot of thinking around that. There's also been, of course, some proposals to have kind of a master AI regulatory body and some kind of heavy-handed regulations. And then there's the European approach in the recently passed General Data Protection Regulation, which has some very specific requirements around things like algorithmic explainability, the idea that if you make a decision that has a significant impact on the individual through automated means, you must provide them an explanation.
And that's EU?
That's in the EU.
Matt?
Yeah, so the GDPR, the General Data Protection Regulation in Europe, that it's causing some problems. They left things intentionally vague about some of the articles in the laws. So basically, one factor is that it gives people the right to see the data that's collected on them, and it also gives people the right to understand how decisions are made based on that data. So if a company has a bunch of data on you and they're deciding on loans, for instance, you can say, okay, what data do you have on me, and what algorithms are you using to make those loans? But yeah, explainability, as Daniel mentioned, it's not always clear what is a good explanation for an AI algorithm, because these are sort of black boxes. So the level of transparency is debatable. You're not sure exactly what factors an algorithm is using or how it's using them. And so there are going to be a lot of lawsuits coming up. Already, Google, I think, has been fined billions of dollars for their use of data on people. And so companies that operate internationally, they are being held to the European Union standards. So it's possible for one company or one continent to create regulations that affect companies everywhere and laws everywhere.
Just to clarify, you're not saying Google's been fined under GDPR yet, billions of dollars?
Weren't they? I thought I saw that somewhere.
Well, it just went into effect May 25th. I don't think there's been any significant rulings.
Okay.
But, people with Google, I guess we'll find out.
Maybe a lawsuit. Maybe it wasn't a fine.
Okay.
Yeah. Let's talk about some of the thorny issues and ethics surrounding AI. What are some of the things that you guys see sort of out there?
Well, the big one that always comes up immediately for everyone is the famous trolley problem, which has been updated for autonomous vehicles, which is the idea of if you have an automated system, an automated vehicle in this case, and it has two unavoidable bad outcomes, hitting running over a child or running over an elderly person. What does it do? And it's going to have to make these kind of decisions. So that question always comes up in a lot of these debates about ethics. Of course, the reality is, fortunately, that scenario rarely, if ever, is presented in the real world. I think the ethical questions around AI are often very similar to the ethical questions around any use of technology, which is, how do you manage trade-offs, and how do you make sure that you're not harming individuals, and how much oversight and awareness do you have of the actions you're taking and their consequences. And so, with AI, there's been a number of concerns raised, partially because of the lack of diversity among the professionals in the field. As a STEM field, it has lower representation of minorities, of women, and that can reflect some of the biases that are manifest in the systems. There's biases, of course, in data that exist and are used for training these systems. A very specific example of this is around facial recognition, and different facial recognition algorithms will have different levels of accuracy for different groups. So it might, in some cases, be less able to recognize an African American versus a lighter-skinned individual, or there'll be differences even between genders or other scenarios. And then there's questions of, well, how are the organizations that are deploying this technology, are they aware of those biases and these problems, and what steps are they taking to mitigate that? And how does it, I think one of the most important questions is, and how does this compare to the current status quo? Is the technology, does it have bias, but it's better than what we have now? Or is it making things worse, and these biases are now maybe in a way hidden? And so there's a lot of conversation around just awareness of where the problems are. And I think companies are becoming very acutely aware of these issues. But some industries and some applications, I think they've moved further in figuring out how to address them or how to start addressing them.
And AI ethics?
So fairness and bias is a big topic. There was a recent news story about the Compass software used for predicting recidivism in criminals. And there was a report saying that it was biased against blacks versus whites. But then there were other stories saying that it was unfair in certain ways, but fair in other ways. And so it raises these philosophical questions about what do we mean by fair, what kind of fairness do we care about? And then there are trolley dilemmas. So should we prioritize certain outcomes over others, like young people versus old people in these things? And there may not be stark things like run over a person versus drive off a cliff, but there might be things more subtle, like if a car is between a tractor trailer and a bicyclist, should it go like a few inches one way to endanger the bicyclist, or the other way to keep the driver safer, things like that. And then there are autonomous weapons. That's another topic. There was recently a boycott of a big research university in South Korea over concerns that they were developing autonomous weapons. And then people have been quitting Google because of their involvement in military research. And then more far off, there are questions about sort of existential concerns about whether robots will eventually take over humanity and kill us all. And some people say that that's just sort of clickbait, and other people think, no, this is the most important question facing humanity right now.
So we've got about 5 minutes left, and I want to get to a question for the journalists in the audience. Do you guys have some suggestions for resources for journalists who are new to this issue, ways that they can get up to speed on the issue? Let's go with the journalist first.
So if you're a science journalist, you're probably used to looking at journals for research. In computer science and AI, it's a little bit different. It's conferences where the big research comes out. So you want to pay attention to conferences. There are certain big ones that you would look for, like NIPS, the Neural Information Processing Systems, AAAI, IJCAI, ICML. And then there's a website called Archive, ARXIV. So most of the papers at these conferences are actually posted on Archive first. And they're not peer-reviewed yet, so you want to be careful about that. But a lot of them do get reported on, and it's a good place to look for sort of up-and-coming findings.
Daniel?
Well, I guess I'd be remiss not plugging our own work at the Center for Data Innovation, because we do run a free weekly newsletter where we highlight kind of 10 innovations that we see around the use of data, and most of it's right now around AI or the Internet of Things. And that's where I think it's just really interesting to talk with also the startups in this space, because so many of them are tackling really very specific but interesting problems around using AI. I was talking to one recently who was using AI for handwriting recognition, but one of the things they were able to figure out is that they could determine gender about who someone was writing about based on the writing style. There's something in there. They had no idea why, but they were getting really good results with this. And exploring these questions, that some of the questions might lead nowhere, but some of the questions lead to really interesting findings, and you just see people who are having access to new data and new insights around what this technology can do.
And if you're brand new to the field, a complete newbie, are there any like primers or sort of FAQs that would get you up to speed that you can think of?
There isn't any particular one that comes to mind, but you'll find a lot on Google.
Yeah, we can Google it.
Well, there's also been some, Coursera has run some good courses, Udacity, some of these other MOOCs, where there are good opportunities for even someone with very little experience to basically actually see how the technology works and play around with it themselves. And I think that's one of the best ways to really get a feel for what it can and can't do, is by getting some hands-on experience. There's I think a link we shared on Google Quick Draw. They've put out a couple of fun games for that allow individuals to just interact with some of this technology and see kind of a little bit more about how it works. And so those are always fun. It's just to kind of play around with some of those tools, and you get a feel for what its limitations are as well.
And we're going to include that resource in the resources section that is associated with this video. So.
And I think it would be important, if you're covering the advances in AI, to also include its limitations and to include caveats and say, maybe this algorithm beat people at this, but also what can't it do, or what were the constrictions on this? Why is this sort of a narrow application?
All right. So our thanks again to Daniel Castro, Director of the Center for Data Innovation, and freelance reporter Matthew Hutson. Resources from this webinar will be posted for your use on NPF's website at nationalpress.org, where we make good journalists better.